All right, so here's what problem 38 is describing. So if you're standing in some shallow water and you're looking, your line of sight, you're looking straight down, and it appears that you spot a rock laying in the water. Well, based on the laws of refraction, that's not where the rock actually is. The light is bent a little bit, and so the rock truly is located in this spot, a distance of d away from where you think it is. And so what this problem is asking is to find all these different measures, x, y, and d. It's also telling you or showing you, if you look at the angle that's formed right here, which they call angle or theta 1, and its relationship to theta 2, which is the kind of bent angle. It wants you to find what that measure is. So they tell you a couple things. They tell you that the height of the water is 4 feet, so this length is 4. They tell you that this angle right here is 70 degrees. And then they ask you, or they give you the index of refraction for water, which they say is 1.333. And they tell you what that index represents. It represents the ratio of the sine of theta 1 over the sine of theta 2. Okay, so what we're going to do is we can use this information. Since they gave us theta 1, we can plug that in. Okay, so plug 70 degrees in here, and we can actually solve for theta 2. So if we set up our ratio, sine of 70 degrees is equal to 1.333. Okay, and we have the division by sine of theta 2. If we were looking to solve this, if we multiplied both sides by sine of theta 2, that gets this out of our denominator. We can then isolate the variable, or the expression with the variable, by dividing both sides by 1.333. And so we get the sine of theta 2 is equal to sine of 70 over 1.33. So I'm going to go ahead and calculate that. Sine of 70 divided by 1.333. And when I do that, I get my ratio 0.705. And then what can I do to actually solve for this angle measure? So the angle itself is going to be the inverse sine of that ratio. So if I take the inverse sine of this, so green diamond y, inverse sine of that ratio, and hit enter, I get my angle measure to be 44.8 approximately. Okay, so there is my angle right here, 44.8 degrees. All right, now once I have that angle, I can find x because I have this right triangle involved. I now have a known angle. I have a side opposite that angle and a side adjacent. So opposite and adjacent is related by what trig ratio? Again, tan. So I know that the tangent of this known angle, the angle that we just found, 44.8, is equal to the ratio of x over 4. And so now it's just a matter of solving this. Multiply both sides by 4. And I get x is equal to, so 4 times the tangent of this angle is going to give me 3.976. So there's my length here. And now the next piece of information that I can find is my whole y value. I can find my y value by looking at this large right triangle that's formed, the one that's to the image of the rock. Because if you use properties of geometry, these vertical angles, this angle of 70 degrees is equal to this angle of 70. And so I can use this whole large purple triangle. I have a known angle of 70 degrees. I have a side opposite it that's unknown, y, and I have an adjacent side to it, so opposite and adjacent, once again, is related by tangent. So the tangent of 70 degrees, this whole angle here, is equal to the ratio of opposite side y over adjacent side 4. We'll do the same thing to calculate it. Just multiply both sides by 4 times the tangent now of 70 degrees. I'll put a decimal in there so my answer is displayed in decimal form. And when I do that, I get about 10.99 as my y value. And so my final step in this, the last piece of information that I would need to find would be d. Well, d itself is equivalent, it's a part of a whole, so if you take the whole thing y and you subtract the other part x, you'll be left with d. So if we took 10.99 and we subtracted the 3.98 approximately, you'll get your solution. Well, we can just use the exact value. So 10.99 minus 3.98, and you get 7.014. Again, I don't know how many decimals. You'll move these. Okay, but those would be your different measures.